Okay, good morning everyone. Welcome to the General Physics 2. So let's get started. So first I need to explain a few things, but maybe let's introduce our TAs, Terry and Darian. They are excellent graduate students, expert on physics. So if you have any questions, you're welcome to ask them. You guys can answer any questions, right? Any physics questions, right? So, okay. And then I also need to explain that, so this class is X class, right? Who is taking this class as X class? Okay, you're taking X class. But the X class people should have another class at the same time, no?
Yeah.
But you're skipping the other class?
Yeah.
Good student. Good. Oh, you're welcome to skip other class and then come to mine. What's the name?
Chinese name?
English name.
Yeah.
Oh, do you have Japanese name? That's better.
You can call me Leon.
Leon.
Yeah.
Leon. Okay. Welcome, Leon. Okay, good. But for some other X classes, people are online, right? So this is why. My microphone was not open. So, oh, sorry. How about the speaker? Should I use mine? Why don't I use mine? Because microphone is mine. Okay? Okay. So online people, can you hear me? If you cannot hear me, just speak up. Okay? All right. So some people are online. So I need to record here my older lecture and then put it online so that other people, when Leon is taking other class, so he can watch the video later. So I need to record it. And also so that online people can ask questions. This is online Google Meet. You guys got the link email, right? So if you want to join online, you can join online and then you're welcome to ask me questions, whatever. And as you noticed, this is X class, so I don't take attendance. So it's up to you. Can you please come in? There's some people outside of the classroom, which is not good. So maybe you can come here or come here. Yeah, sorry for the inconvenience, but like I said, this is only today. So next week you have plenty of seats. Then where was I? So I don't take attendance. So the important thing I think is you guys understand the physics, right? So if you understand, you don't have to come here. It's also the important thing is you guys understand the physics. So if you want to, study with a textbook and you understand the physics, that's okay, right? You don't necessarily come here. This here class is to help you. So if you read a textbook and you don't understand, then you can come here and ask me questions or listen to lectures. So the important thing is you understand physics, okay? So, but then often this happens. Okay, the teacher Tomo doesn't take attendance. Okay, I don't go to class, I sleep, right? And then you don't study physics at all. And semester is finished. I don't understand physics at all. That's not good, right? So if that's the case, you guys should come here and then we can have fun. Okay, so that's the thing. And then see, there are more things to. So I don't take attendance, but then as I explain, or Terry and Darian explain later, so there are two presentations that is going to decide your grades. Okay, so please don't miss those two presentations and two reports. Once during the semester and then once at the end of the semester. This is going to be group presentation. Terry and Darian is going to explain how to do it later in more detail. But please don't miss those two presentations. If you miss one of these, you are very likely to don't get the credit. So please make sure to do this. Then if you're taking X classes, then you're still, I still ask you to come here to make a presentation. So those presentation days, please come here and then do a presentation here, okay? And then you can choose the date of presentation. So, if the other class, there are some activities, then you can avoid that, okay? So please don't miss. Then this class has a lot of funding. So we're selected by MOE's program, research program, and also this NTHU's, what is it, English EMI class, English as a teaching media project. So, so there's some fun here. So the MOE project, it's interesting to use movies to learn physics. So your presentations are related to movies. So every time you come here, you watch movies. It's a fun class, right? So you're welcome to here. It's better to watch movies on a big screen rather than on your cell phone, right? So you're encouraged to come here. Then the other one is to use English. We are actually already using English, but in your report, I want to include one English word, one physics English word that you pick up. So that's a program, okay? And that program is actually paying these guys. And then, actually, if you want to watch some movies, I can pay for you. I mean, not on the movie theater, but to watch it on your computer, So that's the funding is coming from. And also, we bought these kind of things from this funding. I will explain a little bit about more about details later. But okay, first I want to introduce myself a little bit. I'm just waiting for other students to come in. So I'm Tomo. You can call me Tomo. I did graduate school at the University of Tokyo. And at that time, I was making a 3D map of the universe using this 2.5 meter telescope. So this 2.5 meter. And then one of those fibers can measure the distances to galaxies. And I was making a largest 3D map of the universe when I was a student. And then I went to Johns Hopkins University. I joined the Hubble Space Telescope class. Today I'm going to show you a movie, Gravity. Have you seen a movie called Gravity? No? No? Really? Okay. Maybe you guys enjoy watching it. But George Clooney? No? Do you know who is George Clooney? No? You don't watch your movies? You just study physics? Anyway, in that movie, Hubble Space Telescope is destroyed by these space debris. So that's actually, we are building a camera for Hubble Space Telescope and then installed one camera on Hubble Space Telescope. That's something similar that George Clooney was doing on Gravity. So that's what I was doing at Johns Hopkins. The people outside of classroom, could you please come in? I think it's not good to listen to. You guys can come here. Yes, I'm talking about you, the white shirt. Yeah. Come here. Just you can come here. Here, there's some space too. Okay. Then someone has microphone on, but fine. Okay. Then I moved to JAXA, Japanese Space Agency. There I was with the Akari Space Telescope team. We launched a space infrared telescope to the space, and then this is the right. Do I have a pointer? Maybe I do. Here. Okay, this is a telescope, space telescope, because it's in a clean room. Because I'm dirty, so I'm staying outside. I cannot get close to the telescope. And it was launched with M5 rocket. at the tip of the rocket. This telescope is here. And here I was working on the cosmic star making history. Or maybe I should connect this to here, then I can do automatically. Okay. Then I was at the University of Hawaii, not to have a vacation, but Hawaii is very good. There's a Mauna Kea Observatory, and it's a very good place to put telescopes. So all the countries' major telescope, big telescopes are in Hawaii. So there I was working on dark energy. And then after that, I was at Niels Bohr Institute. I was working on supermassive black holes at very distant universe. So this is one of the supermassive black holes that I found. This is like 6 billion times more massive than the sun, supermassive black hole. And then it was on a newspaper. They said this is like a Nintendo 64 Super Mario's. You know the Koopa? The blah blah, right? It looks like this, right? But it's not that. This is supermassive black hole. And then now I'm at Tsinghua. And here at Tsinghua, I'm working on 3 different topics, which I very briefly introduce. Who wants a Nobel Prize? Do you want a Nobel Prize? If it's free, you take it? Okay, right. Who else wants Nobel Prize? It comes with, what is it, 100 million US dollars, right? It's still there? Okay, let me, so I think I should first share, then where's my cursor? I think I should first make a full screen and then share, right? Hey, microphone is not working. Do you have internet connection? Yeah. Can online people still no voice? Okay. Sorry, my microphone is not working. So can we switch to yours? Yes. Who is raising a hand? I think I should do the slideshow, and then I share the screen. Okay. Yes, I did. It's off. Okay. So let me tell you how you get that Nobel Prize. So this is solar system. The tuning is here. It's very small. How many planets are in solar system? How many? Just guess. 1? More than 1? Yes, that's right. You're a genius. It's more than 1 because we have the Earth, right? We have 8, right? And then so 8 planets are here up to Neptune. Okay. And then recently, because of the advancement of a telescope, we started finding very small dwarf planets. Pluto, if you remember, Pluto was a planet before. But now it's, because it's so small, now we call it a dwarf planet, because we started finding many, many of them. If we once we find many of them, it's weird, right? Why Pluto is a planet and these guys are not? It's not fair, right? So Pluto is now dwarf planet, and we found many of them. But surprisingly, all of these dwarf planets, it's only on one side of the solar system. They're in this screen, on this screen, they're on the left side of the screen. But there's none here. What's going on? Why we don't find it? This is like you go to Taipei station and everybody is on one side of the Taipei station and there's no one on the other side of the Taipei station. That is not going to happen, right? That is statistically not going to happen, right? In Taipei station, it's chaos, right? Everybody is going everywhere and people everywhere, right? It should be, the universe should be like that. So this is statistically 99.993% impossible. So there must be reason why this is happening. And then, after many, many considerations, the most plausible story is this. There must be another giant planet on the other side of the solar system, and this giant planet is kicking out small bodies because of its gravity. If there's a giant planet here, the small bodies like this is going to be kicked by the gravity. If there's a giant sitting here, then no one wants to sit near a giant, right? People sit here, right? So that's the same thing is happening. So this is that dynamically there should be something here. But we haven't found it. So that's why we're looking for that. And it's a matter of time. So now all the researchers are looking for this. If you find it, you get Nobel Prize. What's your name? Angel. So you find it, you get Nobel Prize. It's not difficult. you just need to find it. Where's it? Where's it? Right. So then, well, actually, this is very far away. 700 AU. It's one estimate 700 AU. So this is like 10 times more distant than Neptune. So it's very faint in optical light. So it's very difficult to find. But because this is low temperature black body, the planets are low temperature, right? Like 35, 40 Kelvin. So it emits in what wavelength? Who thinks, is it X-ray or optical or radio or gamma ray? What? Low temperature. What do you use when you measure the body temperature when you get COVID-19? Did you say infrared? Who said infrared? Yes, that's right. It's infrared, right? Now the next question. Who has infrared space telescope? Do you have infrared space telescope? You do? No? Okay. How about you? Okay, then who has it? Who has it? There's one person in this class who has infrared space telescope. Who? Did you guys listen to my talk? Did you look at my first slide? Yes, you're listening to my slide, right? I have infrared space telescope, right? So I'm in the best position to find it. I have the data. In this data, somewhere in my data. So okay, I have a space infrared telescope, right? You guys saw this, right? You remember I was dirty, so I was outside of the vacuum clean room, right? So I have this space telescope, and I have data. And in somewhere in data, there's planet 9. If you find it, you get Nobel Prize. And Terry actually is working on it. Did you find it? You found too many, right? How many did you find? 3. That's not correct. There should be only 1. If there's a 3, that's weird. So anyway, Jaya, Terry, I mean, if he finds it, he might get Nobel Prize, right? I mean, I'm calling Professor Terry, right? So that might happen, okay, if he finds it. Okay, so that's one thing. The next thing is I'm revealing the history of the universe using this James Webb Space Telescope. Have you heard of this James Webb Space Telescope? Anyone heard about it? No? No interest in physics? Just want to get the credit, right? So this is NASA's latest Next Direction Telescope, and this is 6.5 meters. So this mirror size is about size of this room, or maybe it's bigger than this room. It's 6 meters. It's from there to here. Maybe there's no less than 6 meters, right? This thing, the sun sealed, solar sealed, is the size of the tennis court. This is how big it is. That's much bigger than the Hubble Space Telescope. It was destroyed by George Clooney. It's 2.4 meters, and this is 6.5 meters. So it's much bigger, and this revolutionized astronomy. So see, this is how big it is. So this is, it is compared to people, it is bigger, right? Much bigger, right? And it's a space telescope. So that's why the image is much better. So this is NASA's previous telescope, and this is James Webb Space Telescope. The image is so different, right? So except for these bright stars, everything, all these tiny things that we for the first time see it. So this is a very good opportunity for stupid students. Even if you're stupid, you write paper about these, and it's the first time people see. So that's very good for my students. I'm not talking about you. Okay. Okay. So this is one of the images of James Webb Space Telescope, and one of my students studied these faint galaxies here. A lot of these faint points are galaxies that we for the first time see. And then this is another galaxy cluster. This is a gravitational lens. And then this is my student. He wrote the first JWST paper from Taiwan about cosmic star mission history. So we're taking advantage of this NASA's big telescope. That's another topic we're working on. Okay. So this is the cosmic star mission history. I don't talk much about details. It's a little complicated, but then our universe is getting old. So this is like this is called staff mission rate, but how active you are, how active universe is. So universe was baby and got active, and then got old. That's what we found. So our universe is getting old. Where are you? Where are you on this problem? Are you here or here? Here. 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 You're getting old. maybe some students are like that. Okay. Anyway, so that's another one. And then the last one, we're building new telescopes in Taiwan. This is also interesting area. So if you look at the night sky with your eyes, you look like this, right? It looks like this, right? But if your eyes can see radio, then it looks like this. So if you see the radio, there's a lot of explosions. Actually, about 5,000 every day. There's explosion in radio. We just didn't notice until recently because our eyes cannot see the radio. And then we don't know what is the origin of this radio burst. So it's one of the biggest mysteries in astronomy. This is called fast radio burst. Then one of the problem is, maybe I can pray again. One of the problem is this radio burst disappears very quickly in milliseconds. It just appears and then disappears very quickly. That's one of the reasons why we didn't notice until recently. But this is a problem because when we know that something happens, and then by the time we want to know the detail and then point the telescope, it disappeared. So we cannot study the detail. So that's a problem. So to fix the problem, we are building a new telescope in Taiwan, which is this. So we want to pinpoint the location of these birds. So we are building something called interferometer in Taiwan. So we put antenna like this in all kinds of places in Taiwan, and then use this as one telescope. Have you heard of interferometer? It's simply speaking, we connect this telescope and use it as one telescope. So this becomes one gigantic telescope like this. And then big telescope can pinpoint the location of the birds. And then we can do that for all of the birds. This is, next step, next generation telescope. Then we are putting it on a beautiful island because we like islands, like a green island. And this is, Donsha Island or Mars Island, and in addition to Nantou Mountains, because this radio frequency is actually overlapping with this. Who has cell phones? You don't? You're lying, right? Everybody has cell phone, right? Who doesn't have a cell phone? See, everybody has a cell phone, right? Please destroy it now. Because it's a noise for our telescope. You guys are emitting the noise. See, there's a noise, right? It's from your phone, no? Okay, so this is why we avoid people. We need to go to places where no one lives. So that's why we are going to Donsha Island well, actually we're building one station in this Ogasawara Island in Japan, and no one lives. So then we get the clear signal. So that's we got a very big research funding for this, and then we're building telescope. So that's another exciting field. Okay, so that's sort of introduction of me. Okay, it's very exciting 3 topics for me, but I see some people started sleeping, so maybe let's go to the schedule and introduction of the class. Okay. Oh, by the way, I did the self-introduction, right? Guess what's going to come? Guess who is going to do self-introduction after me? Okay? Just think about it, okay? And then schedule, okay. So you guys are probably more interested in this, right? So classes, class is 150 minutes per week. So 75 minutes on Tuesday and Friday, right? So we start from 8:30. Right? Who came here at 8 a.m.? No one? You did? Oh, I'm sorry, but you guys sent the email, right? Don't you get the email that's saying from 8:30? Or you wanted to keep the seat? Or you wanted to see me earlier? So that you came? Okay, good idea. But then class starts from 8:30 next week. From next week, okay? So then this semester, I'm going to 3 conferences from September and then twice in November. So there will be no class on these dates. I'm sorry for the inconvenience. It's still a holiday in Taiwan, I believe. So these days, there's no class. So even if you want to see me on these days, unfortunately, I won't be here. So yeah, please don't be disappointed. Okay. Then, if I count, there are about 170 students taking this class. You take a good picture. You don't need to take a picture. Terry and then Darian is going to send the email with more details. Okay. And then Terry and Darian is going to separate you guys into groups, and then please make 2 presentations and then pick a presentation day. And then Terry is going to show you this now. Okay, so maybe we switch. Do you want to show the this instruction and explain a little bit? Okay. Or should I explain? Or maybe you explain. Anyway, let's show this instruction. So I should stop sharing, right? Maybe you should use the microphone, no?
Can you switch to
Oh, I should show this. Okay. Like this? Okay. Okay. Yeah. Okay.
They are
Come here. Because you need to be in the camera.
so hello everyone. I'm Terry. There are two presentations in during this class, which are regular presentation and final presentation, and I and Darian already scheduled the date for each group, and if you want to join, later I will send you the link to the.
Okay. Why don't we explain about more detail about the presentation before discussing it? Yeah.
Okay.
Yeah.
So for the regular presentation, each group will present in 20 minutes, 12 minutes for the presentation and 8 minutes for the Kahoot quiz. You need to pick up a movie scene and then explain what's wrong with the physics in the movie, and and what happened, and then you explain. You make a movie introduction and then explain what happened with if the scene follow the real physics law, and before you make the presentation, you should submit the report. So in the report, there are 5 parts. The first part is the movie introduction, and the second one is the physics law in the movie, and the third one is what physics did you learn related to that movie, and explain how each group member contribute in your own project, and then the final one is explain the one physics English word that you learn through this project, and then you have for the presentation you have to submit in PDF file, and later I will send you this instruction and sign up sheet.
Okay, so how many people in one group?
Actually, because we have 117 people and we only have 22 groups, so some of group may have 6 people, but no more than 6 and no less than 5. Yeah, you can team up with other students, and we set the deadline for the sign up before the next class on Friday. So after the deadline, if student who has not registered, then I and Darian will assign them to other group to make sure each group have 5 to 6 people. And then
So the presentation is by group presentation, but then please take turn in a group of 5 or 6 people, and then so that make sure everyone has a chance to speak. Yeah, so you make a group, and then don't let one person talk about the whole thing. Please take turn, and hopefully one person explain one physics. That would be better. Okay, and then report is individual. So in the report, individual report, please explain what part of the presentation you contributed. Okay, I picked this one, and then I explain this physics, something like that. Okay? And then, Terry, please continue.
yeah. And in the final presentation, actually the content is similar, but you have to pick a movie and then, yeah, here. You still pick a different movie from the regular presentation and then explain what's physics wrong in the movie. But the new one is then you create a new video that follow the correct physics law and then upload to the YouTube. Then you attach the YouTube link to your final report. Yeah, and the content in the final report also similar to the regular report. This is also the individual report, and please do not copy and paste each other. Yeah. Later I will send you the instruction with some reference research paper or book and the sign up sheet. So.
Hey, can I explain some examples?
Yes.
I prepared some examples. Maybe we can switch a little bit. Where's my window? So I should here. Okay. I want to share this screen. Okay. Did it work? Okay. Can I do a slideshow? I hope. Yes, it works. Good. Okay, so I hope this works. Is there a way to make a sound? Is it okay to make sound here? Maybe not okay. Anyway, fine. Okay, so have you watched this movie? Do you know what this movie? This maybe TV drama. Do you know what is this? Star Trek. Yes. Good. So here. So suddenly people appeared, right? Is this okay? So that's something called, in the drama, it's called transportation. So with this machine, you PVP and you can transport people somewhere or someone from somewhere to there. That's very convenient, right? You don't need any car or anything. But as you said, it's against the physics law, right? So what is wrong? What physics law is this against? Anyone? Speed of what? So if it's slow, okay? If it takes 10 hours from here to there, it's okay? Eh? Yes, it's weird. Yeah, that's good. But I wanted to, in this presentation, explain what exactly wrong, what physics law is this breaking. Okay, that's the point of the presentation. Okay, are you getting understand? Are you getting understand? Let's go to the next example. Okay, so here. Oh, not this one. I cannot. What is this? So what's wrong with this? Okay, here. So who likes Star Wars? Okay, let's go here. Okay, so now here's a battle scene, right? So the spaceships are fighting each other, shooting something each other. And then ships are flying to avoid those asteroids or rocks. And there must be oh no, I hate Star Wars. Again? Okay. Okay, so now spaceships are fighting each other, right? And then there are some explosions and things. Okay, so what's wrong here? There are many things that are wrong here, right? Can you point one? Yes, that's right. So there's no oxygen, so fire, yeah. There's no oxygen. How the explosion happened? That cannot be true, right? That's good. What's the name? Kyle? Karen. Okay, good, Karen. How about other things? There are many things wrong here. Okay, so you see these green, what is it? Green missiles, right? Can we see it? When there's no oxygen, there's no air, can we see it? We shouldn't see it, right? In the Earth, we can see it because there's an air, air is going to reflect the light, and the light is going to come to here. But in space, there's nothing, right? So the lasers even flying. You know that some sensors, right? Infrared sensors. Have you go to bank and try to steal something? then there's a laser, right? But you have watched movies like this, right? And if you touch it, there's a bell is going to ring. You cannot see the laser, right? Unless you have a smoke or something, right? And if you put the smoke, then you can see it, right? It's the same thing, right? We shouldn't be able to see it. And also, airplanes are dodging the rocks like this, right? How do you do that? If you have an air, you have a wing, and then you do this, and then you can go this way, right? But there's no air in the space. So you cannot change that, okay, I go this way, I go this way. You cannot do it with a wing. So there are a lot of things that is wrong in a movie. So I want you to find these and explain about it. Explaining is very important. It's not just, but please explain in a physics, okay? All right. Then maybe What is this? Is this the same thing? I think I need to skip from on the big screen. What is this? This already, we watched it, right? Okay. Okay, and then I recommend to first, don't go and watch movies and try to do it by yourself. I recommend, so there are a lot of books and then papers which I give it references to explain about what's wrong with this. So here's a two example book. So this is, both of them in our library, by the way. So this is the physics of Star Trek. This is very famous book. So why this transportation doesn't work, it explains. And also this is the similar book, Physics for Star Wars. This explains why this space battle scene, what's wrong with that. So please go and do some research. Then you can make a good presentation. You can make your presentation report much deeper. If you do it by yourself, it depends totally on your ability, right? So I recommend reading books. Or whatever you do, you just do a research search first. There is someone who did it for you, so you can just read it. I give you the whole source of differences. So Terry, could we go back to that your instruction page? How do I stop sharing? Here? How do I stop sharing? Here. This one. Okay. So can you share that? Then I can see it, right? Okay. So here, could you go up a little bit? Go up a little bit. So we're going to share this document with you, and then here, can you go up, down a little bit. Down. The references that I want to show. Yeah, so here at the bottom of this document instruction, there are references and then books. Okay, here's the references. There are some papers. Papers are short, but it's more going deeper. And can you scroll down to books? Your books. So if you're good at physics, then I recommend reading those papers. Then you can go deeper. If you're beginner in the physics, then I recommend these books. So see, those books are very entertaining. Don't try this at home. The Physics of Hollywood Movies. Insultingly stupid movie physics. It was very interesting, no? Can you go down? This is the book. These are the books I showed in the screen. Yeah. Bad astronomy misconception and myth of the universe. Yeah, so who believes something lucky happens when all the planets are one line? A lot of people believe when all the planets are in one line, something special happens, right? It doesn't. You can talk about that. And then also say, okay, I wrote down the example. So in a movie Gravity, it's amazing. So maybe you guys haven't watched movie Gravity, but then this George Clooney is a space astronaut. And I think they are working on Hubble Space Telescope, and then they are hit by space debris and it broke. Okay? And then they cannot go back to the Earth. Oh, problem. And then they fly to space station like this. That's not possible because both of these are orbiting the Earth, right? And then they go around the Earth in just 90 minutes. It's amazing speed compared to our speed. And then they're in a different direction, and then you can jump onto from one to one. They are faster than airplane or rocket. Can you jump from one plane to another? No, right? But they do in a movie. So that's clearly wrong, right? And then, say the Armageddon. Who watched Armageddon? It's Bruce Willis? No, you guys don't watch movies? So the Armageddon is some asteroids or comet is trying to hit the Earth. So Bruce Willis is astronauts, and they land on asteroid, try to dig a hole onto the asteroid. You cannot do that because the gravity is so small on asteroids. You cannot walk, right? If you push the ground, you just fly away from the asteroid because there's no gravity. So these kind of things that I want to pick up and explain. Okay. Anyway, maybe I don't need to continue, but there are examples here. So please look at it and then pick a topic. The point is do the research, okay? And then explain the physics behind it. It's not just, oh, this is wrong. I finished in 30 seconds. That's not the point of the presentation. So if you do deeper presentation, going into more physics, then you get better score. Okay, then Terry, can you continue and explain about the grouping and the synapses? So this is, so I want you to make a group and then careful with the cable and then pick a date of your presentation. This is important for X-class students because, you know, I want you to do the presentation here in person instead of online. So if you're taking X class, please choose your presentation date carefully. Here's the microphone.
And we already scheduled the regular presentation date and the final date for each group. You can see here. The first presentation of group 1 and group 2 will start on September 20. So we have 17 days to prepare. So you are highly appreciated to register the group 1 or group 2. And when we finish the regular presentation of group 22 on October 29, we will continue with final presentation. We go back to group 1 and group 2. And as you know, the last class is on December 20. And the last two presentations will take place on December 17. So one class before the last, the final class. Yeah, just team up with other people and then write out your name and student ID.
What we're going to do on the last one?
Maybe you have
no
lecture.
Okay. Fine.
Yeah.
Okay.
Yes. Just team up with other people and then write out your name and student ID here. So if you want to make a group of 6 people, then we have another extra slot here. Yeah. And just choose the time slot that you can prepare the presentation. Yeah. And we need group 1 and group 2 because the first regular presentation date is on September 20. So, yeah. And then later I will send you the synopsis and the report instruction by email.
Okay, any questions about the presentation? Yes, please, go ahead.
Does the presentation date affect the presentation date of report?
report is the same day, right?
You mean submit the report, right? You need to submit the report before you give the presentation. 1 day before. You submit by email. You send, because I put the email here, the email for the submission. This email, chanfix2.NTHU. Yeah. And then remember to name your file like this. GP2 regular presentation or regular report or final report. And here's your group number and your student ID.
So, can we do it 3 days after your presentation? Because I often give you guys homework. So when, first of all, don't worry about the credits. If you make 2 presentations, 2 reports, then you'll probably pass the class. So don't worry too much about it. But every year, some students reported like very short, like half a page, and then this, it looks like she wrote it like in 10 minutes. In that case, if I find this kind of short report, then I give you guys homework. Okay, this is kind of short, so why don't you investigate this and this and this, right? And then I ask students to add these homework to the report. So it's probably better to have it deadline after the presentation.
So three days after the presentation.
Right. Okay. Could you actually change this document at the deadline?
I will send it before sending it.
Thank you very much. Yes. Okay. Someone's asking a question, online people? Okay, please speak.
Can you open the chat box on your computer?
You can just speak up, no? We have a speaker, right? So what's the question? Excuse me, can you provide the link on here? Thank you. Yes, we can. Yes, we can. We're going to present it. We're going to provide the link, right?
Yes.
Okay.
I will send the email later.
Any other questions? Okay. Deadline. When's the deadline of grouping? Before the next class, right?
Yeah.
Before the next class, so before Friday. Because Friday I want to check who has no friends.
Yeah, so if you don't have friends, then your house is
It's up to you. You help them to group up.
we can get our classmates information now, the policy and
Oh, really?
so we can know that who are
That's right.
it's a little difficult for people to come to this class individually and then
Okay, true. Okay, so can help people to group up?
Yes.
Yeah. Okay, good.
So if you have friends, you highly appreciate to register by the link. But if you don't have friends, then maybe TI will help you to make a group and then send the list of group in the next class.
Okay, good. Okay, also maybe we still have a little bit of time today, so why don't you make friends here? So maybe, like at the end of the class today, maybe we have a little bit of time for, who has no friends. You guys can get together and then, say hello, and then decide the date, write it down. Okay, any other questions, comments? Yes, please. Oh, no. Report is 25%. Presentation is 25%. And then we have 2 of each. Terry, can you show that? So presentation is twice, right? 25. And the report is twice, 25, 25. So report is also important.
We have 2 presentations and 2 reports, and each has 25%.
When does the class end? It's 9:50 is the end? 9:50, okay. Do you have any more questions? You guys are clear with the presentation? Karen, are you clear? Okay. Okay. Terry, so maybe you should circulate the seats now so that students can sign up. Okay. Then also, okay, so if there are no more questions, that's all the important information today. And I also encourage you guys keep coming here Friday too, although it's option to attend online. So if you don't have any friends, maybe why don't you gather here and then team up with some other people and then decide a date, sign up. Okay. Okay, so Terry is going to circulate the sign up sheet now. So please sign up by Friday morning, okay, next class. And then if you don't have a class, you can just stay in a class. And then if you don't have friends, you can stay in a class and then try to make friends. Okay. Okay, let's do this. If you need our help to sign up, just come here, find a Terry and then Darian. Okay. And then tell me your convenient dates, and then we try to do something. Okay, so that's all for today, and then see you on Friday. Okay. If you have questions, things, you're welcome to come here.